All right. So yeah, indeed, my name is Yulia, like was mentioned, and currently I work for Elastic. I usually talk about large language models as well and more machine learning, data science elements, since that's my background. But, I figured, like Jody mentioned, the space has been a bit busy lately and thought I'd have a change for once and talk a bit about something different like observability, although that also really ties into the same concepts as well, since I do believe one of the main things that we should be going towards now within the Gen AI space as well is something like Gen AI ops and finding ways to monitor and operationalize it. So it will all tie in nicely as well at the end. But to start with, we're going to talk about observability. There's this one slide with numbers that I have before I'm going to get into more, teaching you guys stuff. But basically just to have some facts backing me up that there's a lot of trends, and it has been for a long time, that everyone's going towards systems that need to be observed and monitored, basically as applications and solutions get increasingly more complex and have a lot of moving parts that have to interact together, and they can break, and then you have to figure out what happened. The need for observability is becoming greater. Again, to get back to the same notion of people working with LLMs and large models and Gen AI as well, there are a lot of parts in there that may not go well, and especially for black box solutions, then you're left thinking, what happened and how can I fix it? So having a standard for observability for all these kind of applications and just thinking of observability as an important part when you're building something is like super important. But again, like you guys just mentioned, this is a Python talk, so I want to specifically look into what does this mean for Python. A lot of the times when it comes to these like DevOps concepts, I think Python tends to be a bit behind the other languages in the way that people look at it. Like, the software developers might say that Python isn't maybe as robust, or that Python developers, which are often, maybe data scientists building ML solutions, don't have the same approach to it as like a enterprise software engineer would for building a different piece of code. So I think observability also looks a bit different when you're looking at a Java or C++ solution, or you're looking at Python code. And maybe the first thing that you would think of, and this is also what I used to do in the beginning, is you just put a bunch of print statements all over your code and you call that observability, which, again, no shame in it, but there are other things that we can do. However, this is a good way to illustrate at least the idea that, people do think we need observability when you're building something. So you've probably built an example like this where you have a function, or you have a lot of different transformations that you want to do, and after every single step, maybe you throw in a print statement just to see what comes out. So to make sure that the solution, like the result that you're getting after each transformation, is still what you want it to be, so that things don't break. And speaking of things breaking, this is also something that people often do when debugging. So you don't just put the print statements there to begin with, because you would be printing out hundreds of lines when you run your code. But rather, if something comes out and you think, oh, what happened? Then you go back and you add print statements and you try to track down when did things start to go wrong. That's, I think, a very typical Python approach, to then look through those logs or like the print statements and see what happened. And this is a very naive approach to observability, but it is, in some sense, observability. However, I think we are all aware that this isn't necessarily a great approach to it, and not something that we can rely on, especially when you start adding more functions and more complexity, and then you can really go back and add print statements everywhere. Maybe the next step forward for that would be something like logging, which does come out of the box with Python as well. Maybe this is something people have used, maybe not, but it is a native package that allows you to have like the different levels of logging that you want to implement, and some of them trigger warnings, some of them trigger errors that actually show up in your command interface. Sometimes they don't, they just get logged somewhere. Logging. And you have the option, to put it into a file, or to put it into maybe a variable and like to do something with it later, which is a bit better than just having the print statement. but it can still get a bit complex to deal with. So imagine, again, you would have to put these logging informations for every piece of your code, or where do you store it and in what format. Then if your application gets bigger and you have different Python scripts, do you overwrite it? Do you share it together? Do those files merge? There's a lot of questions that can come up there as well. And often when you're building a Python app, you might also start using different language parts as well. Like maybe you're building a web interface for it. Maybe you have a database somewhere, and you can really use the same type of logging for different technologies. So the compatibility is a bit limiting in that sense as well. So what do we do? If you think about an observability end goal solution, you might think of something like this. You have all these dashboards and you want to figure out everything that's happening in your application. Can we get to this state while using print statements and logging? Probably not. There's just so much to observe. If you look a bit of these confusing graphs, you will already probably notice that there's also so many dimensions to it. Like some of them mention CPU usage, so that's something to do with your infrastructure maybe. Can you even log that directly from your Python code? There's things like requests and transactions, which probably only happen if you have, again, a web interface or an online thing that people interact with. There's these dashboards and pie charts that are built from metrics. So maybe you want to track, different variables over time and what their values are. There's throughput. Is my application even alive? What is happening? So yeah, that's a lot. I would imagine that's a bit overwhelming. So if your experience with observability is what we mentioned before, like print statements, that doesn't get you as far. And it is really important that you do have this set up in some way, because again, like I said, if you have the application going live and things break, you want to be able to track it down. And that's where the concept of Open Telemetry comes in. What is Open Telemetry, you might ask, if you haven't heard about it before, although I imagine that a lot of you have as well. We're going to kind of scratch the surface for that in this session, but it's such a deep topic that we could go a lot more into the details. But to introduce it, Open Telemetry is an open source technology or approach, I should say, that allows for telemetry to be gathered from an application, regardless of what language it's written in, regardless of what vendor it's built with, regardless of who created it. It should be able to offer observability across the board. And it is actually one of the most fastest growing and used open source technologies out there. So we look at this graph of how various projects within the open source sphere have been growing over time. The number one most famous one is, of course, Kubernetes. And OpenTelemetry is right up there as like the second fastest growing. So if you've heard of Kubernetes and you've seen it widely used in different applications, OpenTelemetry has that far of a reach as well. But again, perhaps not so much in the Python space, although it should. And we're going more in that direction. But it's basically, I think I've seen people call it the language that everyone is talking. So regardless of what kind of developer you are, what kind of language you use, OpenTelemetry is a way for all these projects to be observed in the same way. But I've been throwing around all these terms, and I wanted to also break it down a little bit and see how they all relate together. And you'll have this as a glossary for later. How do these concepts all tie in together? Basically, OpenTelemetry is a standardized framework and toolkit. So they have different SDKs for languages. It's both how do we approach observability and how do we implement observability. What is observability? We have an application that is observable when it has been instrumented. So basically, if we want to have an application that it throws out different outputs, and by looking at those outputs, I already understand what's going on, or if it's behaving as it should, without having to understand what exactly that application does. I don't want to have to look at the code. I just want to understand from the signals that it's giving what is happening. And that's an application that has been properly instrumented. So as I mentioned, that means that it's giving out signals. So an application that I put in here natively, which I want to signify that I don't have to go in and add the print statements when I'm trying to debug something. Even when nothing goes wrong, that application is emitting all these signals so that later on I can look at them and analyze them. I can figure out how it's been performing historically and so on and so forth. So that's what that instrument application should do. And by signals, I mean things like traces, metrics, and logs, which we will go into as well. But like you saw from that really big dashboard, there's all these different dimensions of what those signals can be. They can be the way that people use that application. It can be the way the application runs or what the output is. And all these kind of signals, all these traces, metrics, and logs are also known as telemetry. So that's kind of why all this ties in together and why the project is called Open Telemetry. It's a way to have all these signals from an application that has been properly instrumented, gathered, and be made observable. So I hope that kind of makes sense so far, but we're really gonna go into these a bit deeper. So observability. We are understanding a system without knowing its inner workings. So if you have a Python code that's running, maybe it's a black box, maybe it's ChatGPT or another application that is completely black boxed, and you can see the output that it gives, the response that it gives to you, and how that changes based on different inputs that you give, how that sometimes breaks or it says, I don't know, or I'm going offline. And you should be able, from all those signals that come out, to understand how that application works. And this, again, for Python, maybe is the equivalent of having a print statement in there that sends out the output that you want to interpret. But again, maybe don't rely just on a print statement. Instrumentation, to define it again, is when we are emitting all those signals all over the place. So I don't need to specifically add code to know what's happening. Maybe there's like a place where all these signals have been stored, and I can look back and I can see maybe a month ago, what was the application giving out? How did people interact with it? What were the results then? What are the results now? It's not that I have to go out of my way and add something new. When instrumentation has been implemented, it means that your entire code is observable. And at any point, at any little clink in the chain, I can look and I can know what's happening in there. So as if I have a lot of print statements after every single transaction or every single transformation in my code. And what are these signals? I said that the terms, metrics, traces, and logs, and maybe for some people that already means something, but just to make sure, when we're talking about metrics, we're talking mostly about numbers. So any kind of numeric value that we can track over time. The example we had in those graphs was the CPU utilization or the request rate or any kind of value that can go up and down over time. This can be like a single point in time, or it can be an aggregation over time. So you can create those graphs or kind of time series data of what have these values been historically, what are these values now. Logs are recording of events. You may be familiar with this. For example, when you install a package in your Python code, you will know that the immediate next step is that you have this tirade of lines coming up in your command interface, and you see, oh, I looked for the package, I found it, I started installing it, I'm missing a dependency, something happened that shouldn't have happened most often. So those are logs, right? That's very helpful for us to understand what is happening behind the scenes and where did something get stuck, if that is the case. So having a lot of those logs means that I know every step that the process has taken. They usually come with a timestamp, and they tell me this is the process that I've started, this is how it went. And finally, we're talking about traces, which have even more context, right? So if we see, if you think about those logs as a sequential series of steps that have run, that's very similar to how traces work. So we have this record of how a path has been taken through a system. Specifically, when we look at requests, that's where the most often we deal with traces. So you think of a website. When you click on that website, you're basically requesting first the page. Then you click on the button, you're probably triggering a function that does something, and then it does some math, brings back a result, shows it on your interface again. So all those different steps we would call spans within a trace. These are all concepts that you probably intuitively know or think about, but with the OpenTelemetry naming conventions, then it's everyone's talking about the same thing. Again, it's the language that everyone is talking. So once you look at all these metrics, logs, and traces with those names, it's a lot easier to know how to approach them or what like the default way to deal with it would be. And if you are a visual learner, I also thought let's just have a slide that shows us what we mean by these things. Traces, like I was trying to explain earlier, would look something like this. We have here a way to visualize a GET request, like I mentioned, and it has this really nice graph that I think helps visualize it, that first we're getting that GET request, we're triggering like a few milliseconds later a different kind of function, and we see the different APIs working behind the scenes. We have then a function that gets generated and so on and so forth. So you can really see the spans and how long they take and which specific application they're running and how they all tie together underneath a trace. So then if we have an error message, maybe for this API, we know how that API even got called, from where, so we have the context, and it's a lot easier to drill down and figure out what's happening. Logs, like I mentioned, would just be this series of lines coming in at different time spans, informing us of things that are happening, like when you install a package. And again, the metrics are just numbers that we can track, so we can also very easily visualize it in a graph. Hope everything is clear so far. And then basically, why are we then using OpenTelemetry? Well, there are so many vendors out there and so many solutions out there that can offer you observability out of the box, just like they offer everything out of the box these days. Even within the Python ecosystem, I'm sure there's like specific Python packages or specific, language independent packages that are offered that you could use. But OpenTelemetry, being an open source solution, is a way that you wouldn't have to change all the time. So if you want to change vendors, if you want to change languages, if you want to at some point refactor your whole code, OpenTelemetry can still look the same. So you are able to, within your application, have that OpenTelemetry agent running, and then you have maybe different vendor-specific code and different protocols that then gather your data. But that's not the only way to do it. There are also ways to isolate that vendor-specific code even more. So again, in your Python script, perhaps you have your own code that you wrote, and you have that SDK for OpenTelemetry that collects that data, but then everything outside of that is handled separately. So if you want to use a certain cloud provider, or if you want to use a tool with a subscription, or whatever it is that you would do to look into your observability data, that doesn't have to be part of your code. So that doesn't really tie you in to one solution and its solution specific language or code. And there's also other ways to do it, even more simple than this, which we'll get to in a second. But basically the benefit of OpenTelemetry is, besides the fact that it's the most wildly adopted solution, it's an open source and independent solution. So you're able to just add that to your code the way you would that logging package. Is just more robust and compatible with other things, but you're not tied into this is the only way you can do observability from now on. And if you have a Python code that will then also have a web interface or a database, like I mentioned before, everything can be monitored and observed in the same way. So what that looks like here, I have an example of one of the functions where we did implement OpenTelemetry. You have a bit of code here and there that would say, like I want to start tracing this trace and the different spans. So this is a recommender service that's part of a bigger application. I want to put some information in my logger. I want to maybe collect some metrics. So you see it looks, first of all, very Pythonic because this is the Python SDK for OpenTelemetry, and it can be very simply just added at various steps in your process. And then you can trust that all that data is being handled and saved in a very usable way that you can later take a look at it. And the best part about it is that often you don't even have to add all those lines yourself. So what we were looking at here, if you wrote these in yourself, that would be manual instrumentation. So basically you're adding these steps when you say, I want to collect this piece of data, I want to collect this specific metric, and I want you to track this process. However, OpenTelemetry also allows for automatic instrumentation, especially for compatible services where it can kind of expect how things are going to look like, which most people would use anyway. So again, maybe you're familiar with Jinja that allows you to have like the web interfaces in a certain way. You have URL libs and all these like very famous Python packages that kind of always generate very similar code anyway and would be implemented in the same way. So then you're able to just run this function that says instrument, which would then add those steps at the places where it is needed, so that when you have a web request, you are tracing those spans. When you have certain metrics, you are tracing those, and so on and so forth. And of course, there's like benefits and drawbacks to this. You can imagine when you have it automatically instrumented, maybe it doesn't do it the exact specific way that you would want, but you can always go in and add the manual steps as well. But for those people who say, I don't want to go in and think about how I want to monitor this, I just want it to work, then this is also a very nice way to say, I want to automatically just collect all the data that I need. So then if something happens later, I can look at it. I would definitely recommend trying to do this as much as possible. And now finally, where does Elastic come into all of this? If you have heard of Elastic, I also spoke about this at last year's day, of course. Elastic has different components. It is also an open source solution. We can now say it has been for a while. There's different licensing, etc. But it's also a very widely used standard for using search in your applications and for doing observability and also for doing security. I usually talk about the search component, and again, tying into Jody's talk, there's things you can do with RAG and there's things you can do with searching through your data to get answers. But there's also this super big component of observability that Elastic deals with. And it is widely used by companies to monitor data. You can install these agents into various pieces of your technology and collect all this data, all these metrics, and have it stored into a centralized place. And if that sounds familiar, it's because it is a very similar concept to OpenTelemetry, right? So it's a way that you have your databases, your Python code, your web applications, everything can be monitored and all that data can be collected, and then you can see it in these dashboards. So you may think, okay, then is it an alternative to OpenTelemetry? How does that actually work? And because we're also an open source solution, we wanted to integrate with OpenTelemetry. And what actually happened a few years ago, well, 1 year ago, I guess, in 2023, Elastic basically contributed its schema that it's been, again, an industry standard and widely used, and it's been added to the OpenTelemetry project so that OpenTelemetry continues to maintain it. So basically, all the data that Elastic would collect from applications and the way that people would use Elastic to do observability, it is now completely compatible or the exact same schema that OpenTelemetry uses. So you don't have to worry that, hey, if I'm doing observability in this way, would I then have to change the format of the way I store data to be compatible with that? Or if I want to, change out Elastic, or like I was saying, you don't want to be tied into a specific vendor, we understand that, then it's the same schema, it's the same way that we store that data. And now it is part of the OpenTelemetry project. So that's why we're discussing about these together. So this is the way that is implemented. As I mentioned, like the third alternative to what I showed before, you would have your Python code that has those OpenTelemetry SDKs in there saying collect the logs, collect the metrics. You would also have all the other parts of your application doing that as well. And Elastic as well as OpenTelemetry in this joint way would then collect all that data and store it into a nice dashboard for you. So you can both look through it, but you can also analyze it. You can do things like, anomaly detection. You can search through those logs in a very optimized way. And let's, with our last few minutes, take a look at what that actually, looks like. And I'm going to try to show you. Hope you can still see this. This is an OpenTelemetry demo project. This is actually the OpenTelemetry demo project that you can also see on the GitHub of OpenTelemetry. It's just an example showing you that you have this very complex web project that has some Python components, but also components from other languages. And what you can do is you can run this on Docker. And I went ahead and I already started this because it can take a while. And it's then hosting this website, right? So you can think of any kind of project you want, but specifically a web project. You have this interface that has been put up, the front-end design. And when I want to choose a product, you get other products recommended, which would be the Python part in it, a recommender system that you can write out that then generates new products that are similar. So you can click on them, you can add them to your cart, you can do transactions, etc., etc. So what then happens is, because this application has been instrumented, so again, if I look here, I see that a lot of the OpenTelemetry SDKs have been imported. And in my Python code specifically, I have, again, the logger popping in here and there, which then allows me to observe it into Elastic. So I go to the observability part and I look at my services. And in here, I have all the various services that I am monitoring with these agents and with the OpenTelemetry software. So for example, the Python load generator one, I can see things like the latency and throughput and whatever other web interface metrics I am tracking. And I can even see more details, like the way that the transactions have been run on it. It's mostly GET and POST requests that have been running. And you have these things that you wouldn't want to specifically track yourself, such as, the throughput and how long it took for the website to load. But you also have the specific inner workings of that function. So you can see the errors that came in for various exceptions and how many times they happen. You can see logs, like I mentioned earlier. So here already I have a bunch of errors, but I probably also have information, hopefully like a connection pool was running, trying to find some non-error messages. Here. See, when I started my instrumentation, I started my web interface. Like, these are the steps that happen when you start running your application, but we're just collecting them into the same place. And we're also collecting metrics. Sometimes the application is shut down, so nothing's happening, and sometimes they come in. You can see how these have been collected over time. Okay. Well, I only had one more slide anyway, so I'm maybe gonna leave it on here. But yeah, that's the way that specifically within Python, you can add this OpenTelemetry implementation to, without having to think too much about it, start collecting data about how your application runs, so that specifically when you're trying to make changes or when something breaks, you can definitely, look through those logs, look through those services and the way the data is collected, and it helps you debug. But also when things run correctly, it still collects all this data that is going to be very useful to look at later if you want to optimize maybe the way that people interact with the app, if you want to improve your model, if you want to, do prompt engineering for a GPT solution. Having all these metrics and traces and logs collected is very important. Observability is very important. And again, this is something that is already used a lot more with other languages, but is also great for Python. It's open source. You can change it in and out at any point, but it's an important conversation to be had. And I hope that especially people who are here, learning Python and looking into it, this may not be, the sexiest thing that you would start learning about first, but it is very important. And I also specifically think with LLMs and the way that the AI ecosystem is going, being able to observe things and to implement monitoring for those kind of applications is going to be very important, and it's going to become more of a trend. So yeah, that was it for me. Hope you enjoyed it and happy to answer some questions.